Hello, everyone, and welcome to today's presentation, part of Agilent's Virtual Energy and Chemicals Summit. I am Abby Pell of Labroots, and I will be your moderator for today's event. Now let's get started. Before we begin, I would like to remind everyone that this is interactive. We encourage you to participate by submitting as many questions as you would like during the presentation. To do so, simply click and type them into the Ask a Question box and click Send. We will answer as many questions as we have time for at the end of the presentation. If you have trouble seeing or hearing the presentation, click on the Ask a Question box located on the far left of your screen. I now present today's speaker, George Gonzalez, Agilent Standard Test Program, and an overview, addressing required testing in energy and chemicals. For a complete biography on our speaker, please visit the Biography tab at the top of your screen. George, you may now begin your presentation.
Hello, everyone. My name is George Gonzalez. I work for Agilent Technologies. This presentation is going to provide an overview of how Agilent is working with customers through collaboration in the development of standard test methods. At Agilent, our goal is to deliver scientific, operational, and economic value for your lab. In addition to providing reliable and robust instruments, we are collaborating with customers towards the development of new standard test methods. Agilent is currently sponsoring numerous standard test methods at ASTM and other standard development organizations. The development and publication of a new standard requires approximately 2 to 3 years. I will review the process later in this presentation. Agilent is committed to collaborating with customers in the development of new standards. We will now review the MP-AES Standards Development Program as an example. We will also review a few other Agilent-sponsored standards currently in various steps in the development. Agilent introduced the Microwave Plasma Atomic Emission Spectrometer, or MP-AES, recently, and the decision was made to establish a standard test method at ASTM. We then moved to collaborate to develop 2 standards based on the MP-AES. One was for the elemental analysis of crude oil and residual fuel oil. The second proposed standard is for the elemental analysis of biodiesel. We coordinated and established a collaboration task group, which included 12 laboratories, as shown on the top right. The global collaboration team then ran a pilot study and a full intra-laboratory study over the course of 2.5 to 3 years. As shown on the bottom left, the timeline essentially started with the conception of the idea back in April of 2017. Then we formally introduced the technique at a technical presentation at a June meeting of ASTM D02 Subcommittee 3 meeting and requested some work items for the program and move forward. The timeline follows the traditional ASTM standard development program, and it flows through establishing the task group, proceeding on to preparing a sample set, moving on to running a pilot study, determining and scoping out the full intra-laboratory study based on the pilot study results, and then moving into the promulgation stage of the proposed standards. And I will show and preview some of the ASTM procedural promulgation procedures later in this presentation. I would like to briefly review the organizational structure at ASTM. ASTM is formed by numerous technical committees, and the one we have been focusing on today is ASTM D2, which is the Committee on Petroleum Products, Liquid Fuels, and Lubricants. This committee is formed by 4 different types of subcommittees, which include the Executive Subcommittee, Product Subcommittees, which are defined as the letter designations. For example, D02.D is the Committee on Hydrocarbons for Chemical and Special Uses. And then there are property subcommittees, which are focusing on test methods. For example, D2 Subcommittee 3 is for elemental analysis. And then there are a few coordinating subcommittees. Now, if you notice there, within each subcommittee, there are task groups which are formed to work on ASTM standards. They're issued normally by a work item, which is a focus on establishing a new standard. Next, I would like to review the standard development process at ASTM. New standards are typically justified by industry need or new technology. The proposed test method is presented in concept to the appropriate committee. If sufficient interest is found, a task group is formed to develop the standard. The task group then drafts the test method and performs a pilot study. If the test method is found viable, the pilot study data is used to develop an intra-laboratory study, which is required to establish test method precision and bias. Upon completion, the proposed test method is balloted with subcommittee approval. After ballot, if the ballot passes without any negative votes, the test method moves on to main committee balloting. However, if the ballot incurs negative votes, then the concern needs to be adjudicated to determine the concern and whether it's persuasive or non-persuasive. If the negative vote is found persuasive, the test method must be revised and reballoted at subcommittee. If the negative vote is found non-persuasive through the adjudication process, the test method moves on to main committee balloting. Main committee balloting is performed the same way. Negative votes are addressed using the same procedure described above. If the ballot passes without any negative votes, the test method moves on to the review by Committee on Standards, followed by publication. The collaboration program I described earlier provided a new test method, ASTM D03.D, Elemental Analysis of Crude Oil by MP-AES. The official title is Standard Test Method for Determination of Elements in Residual Fuels and Crude Oils by Microwave Plasma Atomic Emission Spectroscopy. This work, as noted earlier, was completed through a collaboration which included 12 labs. There are no other standard test methods for the MP-AES in the industry, so this provides an opportunity for our customers to use the MP-AES for commercial trade and testing of residual fuel oil and crude oil. Standard test method D8322 provides some excellent detection range capabilities. The valid test result range for each type of sample, crude oil and residual fuel oil in this case, were determined through an intra-laboratory study. I think you will agree that the test result range shown here for each type of sample meets or exceeds industry standards for elemental analysis. So Agilent's test method development program included elemental analysis of biodiesel by MP-AES. This work item 56916 has progressed to subcommittee level and is currently being balloted. I am currently addressing a couple of items that were of concern to some voting members. The standard is currently balloted, and I believe it will move on to main committee later this year and published in the fall of this year. This slide provides some insight to MP-AES performance in testing biodiesel blends up to B100. Again, that's biodiesel blends from B1 to B100. The table shown below contain the balloted test method valid test result range for elemental analysis of biodiesel. The valid test result range obtained by performing the ILS meets or exceeds the current industry testing performance. And I believe you will agree that the MP-AES is an excellent instrument for testing biodiesel blends from B1 to B100. We have also been collaborating with customers to revise ASTM D7845. It's for the determination of chemical species in marine fuel oil by GCMS. The scope of work is to establish precision and bias for this standard by running an ILS. In addition, we have also incorporated 2 new examples of Dean switch systems into this next revision. The revision has been approved, but pending the precision and bias information. Precision and bias is being established by an ILS, which is currently ongoing. The 2 new examples of Dean switch have been incorporated into the existing standard along with minor editorial revisions. Work item 50453, currently being validated at ASTM D02 committee, is going to include a revision to include new Dean switch configurations which are available with Agilent GCs. The diagram on the left is an example of a simplified Dean switch which vents to the splitter vent and uses our purged ultimate union. The diagram on the right allows for fast backflush timing and uses Agilent's CFT. These configurations will be incorporated into the next revision of ASTM D7845, and I expect them to be this standard to be published later in the fall of this year. Another test method revision for D7845 is for the expansion of scope for this standard. The expansion will include an extended capability for additional compounds that have been requested by ISO 8217 specifications. We are currently collaborating with Intertech, which will provide the laboratory, GCMS, and other materials for us to work together in the development of what will essentially become Procedure B of D7845 in a future revision. In addition, the work will require a full intra-laboratory study, and we will require at least 10 laboratories to establish the full precision. This work is ongoing, and as noted in the other examples, the work requires 2 to 3 years to complete, when we will see the standard revised and published with the expansion of scope. Recently, I also worked on the development of a test method for determination of oxygenates in motor gasoline by GCMS. In this case, it would be an addition or revision of ASTM D5769, which is the test method for determination of benzene and total aromatics in motor gasoline. The scope of this method would incorporate the oxygenates into D5769. The work performed included the use of an Intuvo GCMS, and the robustness study and collaboration was conducted at Bureau Veritas at the Houston Technical Center in Pasadena, Texas. The collaboration has gone well, and I have presented this proposed test method at ASTM, and going forward, we plan to conduct a full intra-laboratory study. So to further expand on the scope of the proposed test method for determination of oxygenates in motor gasoline by GCMS, you'll see this table includes essentially the calibration standards that were used to expand the scope and establish the test method for this technique. The range in this case is exactly the same as ASTM D5599. ASTM D5599 is a test method which uses a GCOFID and is the current standard accepted method by the US EPA. In this case, you see that all of the oxygenates meet the industry requirement for determination of oxygenates in motor gasoline. The difference is that we are using a GCMS. The proposed test method has been presented at ASTM and has been accepted to proceed to revision of ASTM D5769 to incorporate oxygenates in motor gasoline. This concludes my presentation on Agilent-sponsored ASTM standards. However, as I noted, we are committed to collaborating with our customers towards the development of new standards. As well as you might have noticed that we are also working on the revision of numerous standards. So moving forward, we will need volunteers to help us work on the development of new standards and revision of standards, which the work will also include intra-laboratory studies. If you are interested in participating, please feel free to contact me. If you have any questions or comments, also feel free to contact me directly. Thank you for your time today. I hope you have a great day.
Start the Q&A portion of the webinar. If you have a question you'd like to ask, please do so now, or just click the Ask a Question box located on the far left of your screen. Now let's get started. The first question is are ILS studies limited to the US?
Hi, Abby. No, ASTM is an international organization, and so we quite often participate, have laboratories participating globally from basically all parts of the world. So the answer is no.
Okay. All right, thank you. And another question we have is, how do we get involved with an ILS study?
Well, the interested parties can go to the ASTM website and then search for subcommittees and technical committees, and then browse down to the standards under the jurisdiction of each subcommittee. you will see the standards listed, as well at the bottom towards the end of the list, you will see a number of work items. As I mentioned in the presentation, there's some work items that were referenced. You can simply log in there and it will send an email to the task group, technical contact, and then you can begin the discussion that way.
Thank you, George. Another question, third question here, is actually from William Barber. And the question is oxygenate, in D5769, any expected time that this will be approved?
So it's not an easy answer, and I tried to sort of elaborate some of that in the process required to establish a standard. In this case, D5769 is an established standard, and so it should proceed along a little bit faster than normal. And normal, as I mentioned, it may take up to 3 years before the standard is a new standard is published. So in this case, roughly about 2 years. And of course, I still need to present the technical report and request a work item. And I don't expect the work item to be requested until June of 2021 next year. So we're looking at about maybe 3 years from now at the soonest. But be on the lookout. I do plan to publish an application note on that determination of oxygenates in motor gasoline in the next few months.
Thank you, George. And our last question here that we have is, do we have to be a member of ASTM to participate in the study?
No, you do not. As well as the earlier answer, you can simply contact the technical contact under the work item, or you can contact ASTM.org and someone will direct you to the correct technical contact, get involved. Now, you still should go to find the work item that you would like to get involved with. And if you have a laboratory, there will be a question and answer to make sure that the laboratory is suited to participate in the study.
Thank you again, George, for that answer. I think that that is our questions for today. If there are no more, I just want to thank you for your time today, Mr. Gonzalez, and your important research. Before we go, I'd like to thank the audience for joining us again, and questions submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand through November of 2021. And until next time, thank you so much and goodbye.
Thank you, Abby.